Cowan here with Chapter 2, Lessons 11 and 12, more equations and word problems. First, before you go on, go ahead and pause your video, check answers from the previous day. Come on back when you're ready. All right, ladies and gents. So today, goal is to use algebra to solve one-step equations. We've already been doing this. Just recognize that sooner or later, we'll be going into two and multi-step equations, so using the algebra steps is going to be crucial. Go ahead, pause your video, set up your paper, and come on back when you're ready. Now, I doubt I need to remind you, but just a reminder, please, every time you do an assignment, always write the directions, write the problem, and then for the algebra, you're going to write the problem, work, solution, and you're going to check it. Now, apologies for the date, whatever the assignment number is, make sure your paper is correct. What's interesting with page 55, folks, is they're big old story problems. So when you write the problem, you're not going to write all the sentences, but you might write something like this, and then go into your work and go into your solution. But you will not be asked on page 55 only, you will not be asked to check it. More on that later, I'll repeat myself later. But for now, let's go ahead and let's get into using the symmetric property of equality. I've had students in the past say, Mr. Cowan, I would really like that n on the left side. Can I simply turn around the equation? And the short answer is yes. The long answer is yes, but you need to be careful. See, I'm absolutely okay with you switching around an equals an equality statement. But when you do so, you must be fair not to change both sides of that equality. Here's what I mean. I don't doubt anybody has any problem with writing 4 and 6/10 down, but I have seen in the past students write the following, and that is not going to fly, ladies and gents. Just look at what you see here, where you see a negative n and a positive 1 and 2/10. And so you can pretty quickly see that that is not going to work. So as long as you are careful, please feel free to change around that statement using the symmetric property of equality. Just like this image shows, if you change that picture around, it's still going to be equal and balanced. And so if I don't change this, I'm going to write n, subtract 1 and 2/10. And notice now, this is nothing new, ladies and gents. We've already done this. We have some amount of money. We've subtracted $1.20. Equal $4.60. But I want to know what was in that envelope before we subtracted. So what shall we do? Let's go ahead and add that 1 and 2/10 in, and of course be fair to both sides. After all, if you add 1 and 2/10 to one side, you have to be fair and add it to the other to keep it balanced. All right, now what happens here? Well, in this case, a positive 1 and 2/10 and a negative 1 and 2/10 make 0. Oh, good. That's precisely what we wanted. The only thing remaining on that left side is n equals. And what do we have remaining on the right side? I would dare say that you can use mental mathematics to solve this. So we believe our answer is 5 and 8/10. But before I get into the check step, I'd like to show you why some of you might be more comfortable just leaving it alone. All right, so how do you get rid of the subtract? Let's add 1 and 2/10. Let's be fair to both sides. In so doing, a positive 1 and 2/10 and negative 1 and 2/10 cancels out by making 0. No, you don't have to write the n plus 0. All right. And now we get into the check. Now, I don't care what you did to start the equation, whether you flipped it around or left it alone, but I'm going to rewrite the original equation just as I see it. Notice here, I have not changed anything. Now I'm going to substitute in, wait, we don't think n is unknown. We think we know what n is. We believe n to be 5 and 8/10. Some of you even put a little question mark above here. Now I have advised several of you, if you wish, go ahead and take your finger, take your hand, cover up that side of the equation and actually do the subtraction. 8/10 minus 2/10, 5 wholes minus 1 whole, and look at there. This is certainly a true statement. So whether or not you flip it around or not, you will notice the original problem. You will notice work, circle your solution, and then check it. On to number 2, where again, I will advise you, you are welcome to flip this around or not. That is up to you. I'm going to leave it be. Remember what this means, folks. We don't have one whole envelope of money. We have a third of an envelope of money, and 1/3 of that envelope is 60 bucks. But I want to know what a third of it is. I want to know what the entire thing is. So what we're going to need 3 parts to make that whole, and we're going to need 3 60s to make that whole. Now, just a reminder that 3/3, 3 split up into 3 parts, leaves a single t. 3/3 is 1. And I've asked you guys before, I've told you guys you don't have to write the 1 if you don't wish. Meanwhile, 3 60s is 180, and that's what we believe to be our solution. But we don't have to believe, we don't have to go on faith. We can go ahead and rewrite the equation, substituting in 180. Go ahead, cover up one spot if you want. 180 divided by 3 is in fact 60. Thus, this is a true statement. That got a little ugly. So again, just a reminder, if you had done the same thing by switching it over, you still have a third of t, you still would have multiplied by 3, you still would have had 3/3 as a whole t, and you still would have had 180. Totally up to you whether you flip it around or not. Onward to number 3, where we have 40 cents per, I don't know, cup of lemonade, but we don't know how many cups of lemonade we can buy. We do know we have $5.60 in our piggy bank. So I don't want to know what 4/10 times x is. I just want to know what x is. Therefore, let's go ahead and split it up into 4 dime increments. And of course, be fair to both sides. We'll split that up. How many groups of 4 dimes can we pull out of there? Once again, reminding you, maybe a little disappearing ink here. 4/10 divided into 4/10, any number divided by itself is 1. That 1's about to disappear because most of you are comfortable without writing that. Now we go off to the side. 5 and 6/10 divided by 0 and 4/10. Oh, wait a second. Let's go ahead and change that to 4 wholes, changing it to 56 wholes. Now 4 goes into 5 once, and 4 goes into 16. Oh, look at that. A very nice 4 times. And so our final answer is 14. But let's check to make sure it works. So I rewrite the original equation. 4/10 times some missing number x. But we don't think x is missing anymore. We think x is 14. Now again, I've encouraged some of you to cover that up. Now I know that 4 14s is 56. But wait a second, Mr. Cowan. We got 1 decimal place. 5 and 6/10 is the same as 5. Ooh, jackpot. Now that looks like a true statement. Now, before we go further, I want you to pause the video and look at these questions. Look at all these problems. How are they similar? How are they different? Pause, come on back when you're ready. So once again, I can remind you, if you look at all of these, you have an original problem and you leave it alone. You have a work step. Your work step, well, and you'll have a solution that you circle and check. With your work step, anything you do to one side, you must be fair to the other. If you add $1.20 to one side, you better add it to the other. If you multiply one side by 3, then you better multiply the other side by 3. If you divide one side, you can divide by the other. It all comes back to this balance. Anything you do to one side, you must be fair to the other. They also have those inverse operations cancel out. In this case, if you have a positive 1 2/10, if you have a negative 1 2/10, that makes 0. On the other hand, 3/3 makes 1 whole, and 4/10 divided by 4/10 makes 1 whole. So you see similarities and you see differences. With that in mind, ladies and gents, I would encourage you to go ahead, start up your assignment, whatever the date is. Directions, problem, work, solution, check for page 53. You know the deal. Write the directions, and then every time you'll write the problem, the work, the solution, and the check. However, page 55, you are not asked to write out all those sentences. So you might say, okay, 3 glasses of lemonade is equal to $48. That's the problem. And then you go ahead and you split it into 3. That's the work. And then you'll go ahead and write your solution. But again, just to be clear, There is no checking on page 55 because if you get the original problem wrong and you check the wrong equation, then that's not going to change anything. You won't even realize it's wrong. Okay? All right, folks, take care, do well. Let's grow. See you.